It's time to take an introductory look at the trigonometry ratios, the trigonometric ratios, and let's consider that you have a right triangle. And I've drawn one here. We talk about, and we're going to focus on three trigonometric ratios: the sine, cosine, and tangent. Now, let me show you how they work. If we want to talk about the sine of A, see, written, that's the way it's spelled, sine of A, we would write it this way. We would abbreviate it S-I-N-A. And we need to put that A in there. That's important. So look what we have here. We have sine of A, and it's always going to be the opposite side over the hypotenuse. Always, that's what sine is. Okay, and we write it this way. We never write it this way. Sine equals A over C. Yeah, we don't do that. That's a sin. We always put the angle in there. Now we have cosine. Cosine of A is equal to the adjacent side over the hypotenuse. See, the adjacent side of the angle. And then tangent, written tan, see, tangent of A would be opposite over adjacent. Yeah, like that. Now, let's look at, we were doing A, let's look at B. Let's take the sine of B. Well, it's going to be the opposite. This time it's B over C. See, the opposite of angle B is side C. Okay. Now the cosine of B is going to be A over C. See? Now because we're dealing with this angle now. And then the tangent of B is equal to B over A. Yeah. So those are the three trigonometric ratios that we're going to, kind of take a look at here. Okay, now let's put some numbers with it. Let's look at these triangles down here, and I have the sine of A is equal to 3 over 5. The cosine of A is equal to 4 over 5. And the tangent of A is equal to 3 over 4. Okay? So notice I've got this 3, 4, 5 right triangle, and there's the sine, cosine, and tangent of A. We could do the sine of B, which is going to be 4 over 5. The cosine of B, which is 3 over 5. And then the tangent of B, which is 4 over 3. Yeah, like that. So every angle is going to have its adjacent side and its opposite side. And it's essential that we understand which is which. Now, let's suppose that I take this triangle, this ABC here, and expand it, make it bigger to A prime, B prime, and C prime. So, in other words, I multiplied every side by 2. Now, let's take a minute and see what we would have. Let's look at this one. Now, remember, these two triangles right here are similar to each other. Okay? So the ratios, let's look at these trigonometric ratios. Let's have sine A prime. Well, it's going to be 6 over 10. Now that reduces to 3 over 5. Notice exactly the same. The angle is the same. This angle here is congruent to this angle. This angle here is congruent to this angle. And of course, you've got your 90. So we've got the same angle. All we've done is made the sides different. But notice the trigonometric ratio is the same. You get the same angle. A prime and A are congruent. All we've done is make the triangles different sizes. But the angles are still the same. Now look at this. What if we've got cosine of A prime? Well, cosine of A prime is going to be 8 over 10. And let's see what that reduces to. 2 will go into 8 4 times. 2 will go into 10 5 times. So look at that. We get the same ratios. It doesn't matter how long the sides are. What we're concerned about is the angle. So let's look at this. Let's look down here at this 30, 60, 90 triangle. And the lesson we learned is that, in this case, let's just make the hypotenuse simple. Let's just make the hypotenuse 1, because the lesson we learned is that the sine of A is equal to the sine of A no matter how long the sides are. So the sine of a 30-degree angle is going to be the sine of a 30-degree angle no matter how long the hypotenuse is. Okay? So for simplicity's sake, let's just make the hypotenuse 1. Now this is a 30, 60, 90 triangle. Remember, the side opposite of the 30 degrees is half the hypotenuse, and the side opposite of the 60 degrees is half the hypotenuse times the square root of 3. Okay? Now let's look here. Let's see if we can figure out what is the sine of 30 degrees. The sine of 30 degrees is 1/2 divided by 1, or in other words, 1/2. Here we notice something here. The sine of 30 degrees is 1/2, and it doesn't matter what the hypotenuse is. If the hypotenuse was 4, the sine would still be 1/2. Okay? Think about it. Let's just, for the sake of argument right now, say the hypotenuse was 4. Then the side opposite the 30-degree angle would be 2. 2 over 4 is 1/2. Now let's look at cosine of 30 degrees. The cosine of 30 degrees is square root of 3 over 2. See, adjacent over hypotenuse. So you got to dig what I'm saying here. Always the sine of 30 degrees is 1/2. The cosine of 30 degrees is the square root of 3 over 2. And what is the tangent? The tangent of 30 degrees. Well, it's 1/2 divided by the square root of 3 over 2, which is 1 over the square root of 3. See, because we invert and multiply. So always the tangent of 30 degrees is 1 over the square root of 3. Now we could do the same thing. Let's talk about the sine of 60 degrees. Okay? The sine of 60 degrees is square root of 3 over 2. See, because it's the opposite over the hypotenuse. The cosine of 60 degrees is adjacent over hypotenuse, and the tangent of 60 degrees is square root of 3 over 2 divided by 1/2, which is just going to be the square root of 3. The tangent is... So look, no matter what the hypotenuse is, the sine of 30, cosine of 30, tangent of 30, sine of 60, cosine of 60, tangent of 60, they're going to be consistently, they're going to be the same. Okay? The tangent of 60 is equal to the square root of 3, no matter how long the hypotenuse is. The sine of 30 is equal to 1/2, no matter how long the hypotenuse is. Okay, now let's talk about the 45 degrees. Now remember, this is a 45, 45, 90 triangle that we're looking at right here. That being the case, we can talk about the sine of 45, because look, remember, there's a relationship. The side opposite, if your hypotenuse is 1, this side over here is 1 over the square root of 2. Okay? Remember, it's the hypotenuse divided by the square root of 2. And this down here is going to be the same. Okay? Because it's 45, this is 45 degrees up here as well. So look, we've got sine of 45 degrees is 1 over the square root of 2. Or, if you rationalize it, square root of 2 over 2. The cosine of 45 degrees is the square root of 2 over 2. And the tangent of 45 degrees, well, let's see what that is. That's opposite over adjacent. Well, that's 1. Okay? So dig that. The tangent of 45 degrees is always 1. Cosine of 45 degrees, always 1 over the square root of 2. Sine of 45 degrees, always 1 over the square root of 2. And it doesn't matter what the hypotenuse is. These are constants. These are always true. Now let's see how we can use that. Let's suppose we want to know how tall is this tree. And we know that we've got an angle of, we're going to call this the angle of elevation, from the ground to the top of the tree. It makes an angle of elevation of 60 degrees. And we want to figure out what h is. Well, look at this. We want a way to relate 60 degrees, h, and 45. Well, tangent, right? Tangent of 60 degrees, look, it's opposite over adjacent. Look at that. Opposite over adjacent. Now I want to know what h is, so I can just multiply by 45. 45 times tangent of 60 degrees is equal to h. See, because what I did was I just multiplied both sides by 45. Okay? And then you could punch that in your calculator to actually get the answer out. But that's the way we can use these trigonometric ratios to solve problems. Like I can find how tall that tree is, for example.